For those of you who may not be familiar, NASEO is a nonprofit association of energy officials from across all the states and territories in the US. We serve as a resource for state energy offices, and we host a range of committees and support regional dialogues and informational events and conferences that facilitate peer exchange and sharing of best practices. And we're headed by a board of directors as well as regional representatives from across the country and regions. And the range of committees that NASEO runs are listed here. I won't go through them all. What I will mention is that the work you're hearing about today lives within the electricity work at NASEO. And for our agenda today, we're going to give you a little bit of background, which I'm going to lead, and then I'm going to turn it over to the project team to walk us through the OpenBCA, including its intended uses and applications, the type of value streams that are supported, information about the release package and IT requirements, and then a live demonstration. And our intent is to leave some time for you to ask questions. Please pose those questions in the chat box. Some of them may be answered directly for you, but those that would benefit sharing with the whole group of attendees here, we will share those at the end of the presentation. Okay, so to get us started, by way of a little background, on the next slide, you will, there we go. You will see here a little background around NASEO's National Energy Screening Project, which is relatively new to NASEO. It moved over from E for the Future back in January of this year. And importantly, for context for learning about the OpenBCA is understanding the core areas of what is the National Energy Screening Project. And some of you may be familiar with the National Standard Practice Manual, which provides guidance on how to develop benefit cost analysis tests or cost effectiveness tests. And following the development of the NSPM is a supporting resource referred to as the MTR Handbook, which is a more technical document that provides guidance on methods for quantifying benefit costs related, benefits and costs related to analyzing the value of distributed energy resources. And as these different resources have been developed, the question came to bear as to, well, is there a tool that can be used to model and support benefit cost analysis using NSPM guidance, using and supporting the methodologies in this handbook? And so these are the core sort of products or tenets, if you will, of the NESP work at NASEO. And along with these resources, there are supporting services provided in the form of state technical assistance and facilitation. There is also an NSPM training and certification program that is going to be launched this fall. And on occasion, there is a research conducted on different DER impacts and development of supporting case studies. And you can learn more at the link here. And by the way, this presentation will be shared and posted on NASEO's website, along with a recording after our session today. So again, as we go into, on the next slide, you will see that the NSPM is foundational to the tool that you're going to learn about. An NSPM 2026 version was published by NASEO just this past May. And what distinguishes it from other cost effectiveness guidance documents is supporting the development of a test, cost effectiveness test, that aligns with a jurisdiction's regulatory and policy perspective. So on the left side here in the little Venn diagram, we know of the traditional cost effectiveness perspectives, utility system what's often referred to as a utility system perspective, utility cost test, a total resource cost test, and a societal cost test that presents these perspectives. And many models out there are geared around the sort of traditional perspectives, if you will. And on the right is how the NSPM presents that at the core of any test are utility system impacts, but what other impacts are accounted for is going to depend on your jurisdiction's policies, whether articulated by statute or otherwise, regulatory orders, plans, and so forth. And that test is referred to as a jurisdiction-specific test, or JST. And you will hear reference made throughout the presentation today to a JST, which, by the way, could theoretically align with a traditional cost test, but more often than not, we see that jurisdictions come up with their own specific test that is unique to their jurisdiction. Okay, so moving to the OpenBCA, by way of a little background, lots of folks involved here, including the role of NASEO and National Lawrence Berkeley National Lab, which has provided strategic guidance and is going forward going to be supporting state technical assistance coordination. We of course have the tool itself developed by ICF and Recurve, and you're going to be learning about the range of capabilities of this tool. And together, these four organizations or companies are working together to continue supporting the implementation and use of this tool. On the next slide, I'm going to introduce to you the project team. So of course, it's myself and my colleague, Josh Owens at NASEO, who are really leading the coordination of the project. And we have a team from ICF, and we're joined today by Shram Hari, who's going to be presenting, along with David Pudliner, who's going to be fielding some Q&A. And from the Recurve team, we have Adam Shear with us today, but also supported by other Recurve folks. And what we don't have here, and my apologies, is we should have the LBNL team with Natalie Mims-Frick serving as a coordinator for supporting funding for developing the tool, and as well as Margaret Pigman providing some beta testing. On the next slide, we want to give thanks to the range of folks who have provided some support in beta testing the tool. And importantly, the project really benefited from the state of Michigan, led by commission staff as part of a BCA tool collaborative effort within the state, where it was planning already to develop a BCA tool, and got wind of the development of this project and supported and helped to support DOE funding for this effort. And so we worked very closely with Michigan and its stakeholders through the collaborative to test the tool, to inform the tool, to make sure it would work for Michigan, which had adopted a Michigan state-specific test using the NSPM guidance. But also broadly, the test was geared towards making sure it aligned with the NSPM and could be used by states, and is intended to be used by states around the country as a free, public, open source tool. So thank you to LBNL, to DTE, Consumers Energy, and the Michigan PSC staff for reviewing and providing input to the tool. Here's just a quick image of the landing page on NASEO's website. So NASEO, as a coordinator in its coordinator capacity, this is where you can find all the information, including, I really encourage you, we're not going to be able to answer all the questions today, but I encourage you to review all the supporting tools and so forth, and you'll hear more a little bit about what's behind those tabs for the release package. And you can directly access the tool on GitHub, which you'll be learning more about that in a minute. And we will leave you with information on how to directly access this website. And finally, why this tool? you may be asking yourself. And the impetus for it really was to address some of the challenges that we heard from states facing in conducting benefit cost analysis of efficiency and a full range of other DERs. Some tools out there being limited in their flexibility, being tied to a traditional cost test and not allowing for alignment or easy alignment with JSTs. Often tools out there have very siloed DER analysis, and we really wanted to develop a tool states could use that could cut across different DER types and integrate multiple DERs. Importantly, as an open source tool to allow for transparency in the formulas and calculations and to try to move away from black box type models. And lastly, to ensure scalability and allow for scalability given some limitations of spreadsheet-based tools that can be slow and difficult to scale and to be able to manage larger data sets and address types of impacts and attributes related to things like, for example, temporal and locational considerations of certain DERs. So with that, I am going to turn it over to Shriram, and he is going to give you some background on an overview of the tool.
Awesome. Thank you, Julie. Hello, everyone. My name is Shriram Hari. I am an energy consultant with ICF, and I served as one of the modeling leads for this project. I'll walk you through an overview of the OpenBCA tool, as well as what its intended use cases is and how it can fit into your workflow. So just to reiterate what Julie mentioned, OpenBCA is a transparent open source platform for evaluating the costs and benefits of DERs. This tool is open source and lives on GitHub. It is a Python and SQL-based tool, and all of the code that runs the backend is available on GitHub for perusal as well as improvement. And just to drill down on the transparency bit, again, this aligns with the NSPM's methodology. All of OpenBCA's calculation and methodology is based on the National Standard Practice Manual as well as the MTR handbook. And another thing that we're really proud of is how flexible OpenBCA is. This is not a tool that is limited by inputs for its single jurisdiction. It is adaptable and can fit as many use cases and as many types of DERs as you can throw at it. We have a couple of screenshots on the right from the OpenBCA tool, just as a little bit of a teaser. It provides results on both a JST metric perspective, but also on visual images like waterfall charts and scatter plots. So you can really drill down into what makes a program or a portfolio cost effective and helps decision making in that way. Moving on to the next slide. I do just want to drill down here on what OpenBCA is designed to do and where its boundaries end or where its limitations are. Now, OpenBCA is not intended as a replacement for any IRP or engineering or planning tools. It takes in the outputs from those tools to be used for cost effectiveness valuation. And it also does not generate any avoided costs like energy or capacity on a dollar per kilowatt hour or dollar per megawatt hour basis by itself. Instead, it can use any locational developed avoided costs, either by regulatory proceedings or through any additional IRP modeling to give you outputs for that specific jurisdiction. And again, this is also based on, like Judy mentioned, a JST that is based on individual state or jurisdictions' regulatory priorities. There needs to be a separate regulatory proceeding on how to develop a JST or a structure, and OpenBCA can take inputs from those proceedings to come up with cost effectiveness results and methodology. And OpenBCA supports a wide variety of analysis. It can support multiple DERs individually or side by side to give you results at different levels of aggregation, either at the measure level, the program level, or an entire portfolio that could consist of multiple types of disputed energy resources like electrification, energy efficiency, demand response, even some solar or battery storage. The examples that we're going to show later today include a wide variety of DERs, and Adam will go through that. OpenBCA can also be used to evaluate individual pilots. If you have a certain non-wire alternative or an NPA solution that requires a fixed analysis that is really locationally dependent, if you have avoided costs that align with that use case, OpenBCA can calculate the cost benefit analysis of those types of pilots. And finally, this can also integrate with distribution level system planning in terms of looking at if you have inputs for certain feeders or substations, OpenBCA can give you analysis of what would be the cost effectiveness evaluations for those types of analysis on a distribution system. We have a wider variety of use cases and additional documentation on the webpage. So if folks do want to explore more of this, I would suggest visiting the NASEO OpenBCA webpage to look at those resources. Now, talking about how OpenBCA can fit into your workflow, I laid the slide out into two different boxes. The first is what needs to happen before you can use OpenBCA. And this is really where the development of a JST framework, either through a regulatory proceeding like a working group, where you identify what value streams or impacts are material for your jurisdiction or what reflects your regulatory policy goals comes into play. There's also other factors that need to be considered when you develop a JST or jurisdictional specific test, like how do you treat transfer payments, like utility incentives. And this really ties into what the overall structure of your test will be and needs to be done before you can put those inputs into the OpenBCA tool. The second part is to establish where your avoided costs are coming from. This could be through public resources like NLR's Cambium database. There's also additional modeling that needs to be done, like an IRP proceeding, where you can come up with what avoided costs are applicable for each and individual value stream. And both of these inputs feed into the OpenBCA. The OpenBCA tool incorporates both the JST setup and configuration, as well as additional parameters like what line losses are you using, what is the discount rate, what temporal category do the avoided costs fall into, and calculates your outputs for your cost effectiveness test using those input templates provided and gives you a UI and downloadable tables to visualize the results from that analysis. Now, OpenBCA can be used in two distinct pathways. For this presentation and the live demo, we're going to focus on the standalone pathway. The standalone pathway uses Excel input templates using which you, as I said in the earlier step, define what your JST is and input all of your avoided costs into those Excel input templates. You upload these into the OpenBCA user interface and hit run, and the tool computes the outputs and generates outputs in both an exploratory dashboard as well as providing you CSV or downloadable workbooks from those outputs. The other way you can use it is directly through the SQL or backend interface. This is intended to be power users or for power users or users who want to integrate OpenBCA into their existing tools. You would need slightly more technical know-how in terms of using the integrated pathway, but the GitHub README provides ample resources on how you can connect the SQL tables into the OpenBCA engine and use the output tables that are queryable for further or intermediate calculations. Now, I do want to just finish with how to break down OpenBCA in your head. The actual process for using OpenBCA is very simple. All you would need to do is go to the GitHub repo, download both the desktop application for Windows and Mac, and download the two input files. There's the configuration file and the program input file. You would need to prepare your inputs. That includes defining what your JST is, entering in your system inputs for avoided costs, as well as program and measure inputs, and also establishing factors like line losses, discount rates, program base years, etc. And the last step is to pretty much run the tool. You can run it using the user interface, upload your inputs, validate so that if there are any errors in how the inputs were set up, the tool catches that and flags that for you. And the final step is to just run the tool and you'd get your outputs similar to that screenshot I showed in the beginning of my section. And with that, I will hand it over to Adam to go through the key features in the live demo.
Thanks, Sriram. Why don't I grab the screen here?
Absolutely.
Nice to see everybody here. Thank you for coming. I'm Adam Shear with Recurve, and just for those of you who are not familiar with Recurve, we're a technology provider to help distributed energy resource programs become optimized and grow and become genuine energy resources that can compete with supply side options. We do so through measurement of programs using AMI data. And I just want to thank the project team here, Julie, the ICF folks, the folks at LBNL. This has been a wonderful project to work on. I've been passionate about benefit cost analysis since I got into this industry 10 years ago because I saw just how important it was. Obviously, we're running these distributed energy resource programs, and we're not doing so just purely to save kWh or save therms. We're doing so for a wide range of reasons. And most importantly, the conversion of all of those, energy impacts into dollar and GHG impacts, that's fundamental to, how we value these portfolios. So the NSPM, the National Standard Practice Manual, sets out this framework for jurisdiction-specific tests, and it's a common sense way of saying we have policy priorities that our DER programs need to deliver. We should be valuing those policy priorities in order to have a comprehensive approach to our entire portfolio. And the difficulty of traditional tests and traditional tools is you might be able to construct one for one specific jurisdiction or one specific utility, but when you want to take that framework and make it something that any jurisdiction can adopt, then you need software. You need real software, not just like an Excel spreadsheet to implement something like this. And you need scalability. So, a lot of data intensive programs these days are measuring impacts on an 8760 basis. You have calculations that run across effective useful lifetimes that can span 20, 30 years. You have many measures that you want to look at simultaneously. That means that we're well beyond the bounds of what can be supported by traditional Excel-based or spreadsheet-based analyses. So we need something that is modern for DER benefit cost analysis. We need something that can put these resources on the same footing as any other energy option that we're considering across our entire, not just demand side portfolio, but our entire energy portfolio these days as utilities. So Shriyam and Julie have already mentioned that the OpenBCA has been built to handle multiple types of DERs at once. And I'm also hopeful that the outputs, which you'll see in a moment here, are enable you to gain insights and understanding of how to optimize your portfolio, as well as like the time and locational impacts that your DERs are delivering. That's the kind of information you need to put those kinds of resources into the broader mix of energy resources. Now, also very important is this tool needs to be flexible, not just to configure a jurisdiction-specific test, but also to consider your avoided cost streams that may be coming out of your IRP or may be coming out of other research that you're doing. So we need a series of value streams, and I'll talk in a minute about just the breadth of value streams that can be handled by the OpenBCA. But you may even need to define your own value streams, or you may have avoided costs that differ based on which region of your energy system you are in. So, a good example of that would be you may have a highly constrained region during certain months of the year and times of day. You may run into capacity constraints. But another region of your grid may not, and it may be fine. Well, the capacity costs in each of those two areas may be very different. You should be able to configure that in your OpenBCA setup. And you should be able to define what those different regions mean or what those different subsets mean. In another case, it might be we have a region of high concentration of low income customers. Over here, we have a region of high concentration of market rate customers and so forth. And we have different cost considerations for each of them. You also need to be able to configure things like discounting and inflation. Do you want to look at the results on a real or a nominal basis? Do you want to model out different inflation scenarios? Your jurisdiction may have monthly data for one type of avoided cost. You may have hourly data for another type of avoided cost. You may have annual data for a third type of avoided cost. You need to be able to enter that data as you have it, not sort of be forced to enter it in a way that doesn't adapt to how your data actually lives within your own systems. And then a lot of value streams, and I think we all sort of have an inherent understanding of this, are actually really hard to quantify, including very important value streams like, reliability and resilience and things like that. So, we need ways to say, and this is a principle of the NSPM that I very much identify with. If something's difficult to quantify, that doesn't mean the answer is zero. We need a way to say it's difficult to quantify. We're going to put an adder in for the minute, and that adder might be a percentage of your total avoided costs. It might be just a flat value per project. You should be able to configure that so that you can ensure that those key policy priorities, even the ones that are difficult to quantify, are still represented in your test. And very importantly, if you're used to using traditional tools, you might have some outputs, but it was a big goal of this project team to develop a user interface that was point and click, that allowed you to filter, that allowed you to have nice visuals, downloadable tables, all of this kind of thing that should be part of a modern software package. So you'll see this in a moment when I demonstrate a lot of this. So moving on. The value streams that are delineated by the OpenBCA cover a wide range of areas of impact categories. So we have things like general utility system impacts. Those can be, what are my admin costs? Do I have credit and collection that costs that are impacted by the DER? The electric utility system, and then a whole range of value streams within the electric utility system. These are things like what's my cost of energy, but also ancillary services. And you can have things like greenhouse gas emissions, maybe valued by your jurisdiction. There are, dozen of these electric utility system value streams. Obviously, the capacity costs are very important. Natural gas utility system. I don't want to read them all, but the OpenBCA will handle everything from host customer and societal impacts to your traditional energy system impacts, and will allow you to configure distributed fuels, or delivered fuels, I should say, things like oil and diesel, as well as even custom impacts. So you might have a program that saves water in addition to saving natural gas, and you want to be able to value those water savings or whatever it may be. So we also give you flexibility and breadth in how you configure the impact categories and the value streams of your jurisdiction specific test. And I'll show this in a moment, but this is just a quick screenshot to say, when you get into the input templates for the OpenBCA, you'll see very easy to use drop-down menus, things like this, that are broken out per value stream that allow you to say, should I include this in my test or not, based on what my JST formulation should be, and further options on what your data granularity is and how long the duration of those avoided costs may last, things like this. So all of this, as I mentioned, is part of a software package, and that software package is supported by a wide range of documentation. So we have a full user guide. Certainly in today's webinar, I won't have time to go through every detail of how you configure and run the OpenBCA, but the user guide does. And so for anybody getting started, I would recommend that being the place you go right away. And we have a technical README for those who want to understand more under the hood what's happening in the OpenBCA model itself. We have technical assistance available. We have office hours, and I'll show you how to access some of these resources, as well as value stream documentation, step-by-step instructions, and of course, the National Standard Practice Manual itself for those of you who are new to the concept of a JST and are interested in how to adapt a JST given your jurisdiction's data and policy priorities. So as a software package, the OpenBCA will likely require IT review if you're at a utility or if you're at a commission in particular. This is software that your computer will not recognize immediately. So all of the packages that we've used to put together the OpenBCA themselves are commonly used open source packages and are used in a wide range of applications across many pieces of software. So the OpenBCA itself is mainly Python and SQL. And it leverages a lot of other work. Anytime you develop software these days, you're standing on the shoulders of giants that came before you. So we have specific IT related documentation to help your IT team get started reviewing the OpenBCA, and we're available to help answer questions as needed. So Shriyam just a minute ago gave kind of a three-step broad overview of the OpenBCA process. And these three stages really each have a number of individual steps. So the first step is just go to the OpenBCA webpage, and I'll show you this in a moment. Download the application. But also, you need to populate these input templates. You need to upload those into the interface. You have ways of validating the inputs, and I'll show you how this works. And then obviously running the OpenBCA and then exploring the results and trying to understand not only hopefully, what is the answer of my JST, but what are the details that can help me optimize my portfolio of DERs or a specific program or even a specific measure. So the example portfolio that I'll show here in just a minute we mentioned, the OpenBCA can handle multiple types of DERs. It can do that simultaneously. So we have 5 different programs that span a number of different types of DERs. So in one single open set of OpenBCA inputs, we have programs represented across efficiency, electrification, battery storage retrofits on top of solar PV systems. We have load shifting and demand response, and we even have a hybrid efficiency water saving program. And we also have 2 different regions of this hypothetical grid that we've incorporated into the avoided costs. So these subsets include a highly capacity constrained region, as well as a region where we're not running into capacity constraints. So you'll see how, a program run in both of these regions simultaneously can yield different results because one of those sets of projects is delivering savings when you have high capacity costs, and the other projects are in the region where you don't. So with that, I'm just going to transition right into a live demo. And before I do that, I want to just give you a really, really quick kind of gut feel for what are in these input templates. So there are 2 input templates. And the first input template is where we try to capture all of the JST configuration itself, as well as the avoided cost data. So the avoided cost data will be things like, what is my marginal cost of energy generation? What is my marginal cost of capacity, ancillary services, natural gas system, and so forth? And all of the theme of this particular template is you likely only need to enter these data one time, right? You only really need to configure your JST one time. You only need to enter these avoided cost data one time, or at least only very periodically do you need to do these things, right? You may get another set of avoided cost data coming out of your IRP, a year from now, and then you would need to redo your OpenBCA input. But the idea is everything that you basically just need to enter once is in this first input template. And you can see right off the bat, we have things like my discount rate, am I doing a nominal or a real calculation? What is my discount cadence? My line loss factors. This is where I can enter those subsets. So I mentioned earlier, I have these 2 subsets. In addition to that, I can define my if your jurisdiction has just periods where you break avoided costs into off-peak period, super off-peak period, or my winter is different than my summer, and you can do so routinely, then you can enter a configured set of periods, and then you'll have the option later on of entering data that ultimately just reflects these periods. So maybe the capacity cost in a super on peak period is very high, but during an off peak period it may be 0. You can enter data that reflects your custom periods, and you can do that here. Then I can transition over to this configuration data page, and this is really where the magic happens, where I enter the specifics of my JST. So in this column are just all of the value streams, and we've broken them into each of these impact categories: electric, natural gas, societal, host customer, and so forth. And I just am able to run down the line and say, yes, include this in this test, don't include it. Is this subject to multiple subsets? Do I want to break it out into that North Bramble and South Junction type of approach? And what's my data granularity? So, are these data associated with, for example, energy generation? They're hourly data, but my transmission capacity is just a peak capacity calculation. And you'll see more information on this in the user guide that I mentioned earlier. Finally, once I have all this configured, I just click build value streams, and then all of my value stream tabs will be they will be a template will appear for me that I enter the actual numeric data. So here's my energy generation tab. If I can make it bigger, and I can just see, okay, here's just where I enter all that data. So I don't have time to go into this much further. This is the first input template. The second one I'll just show for 30 seconds, and it's just to say, once you have all that system level data input, now you can configure the nature of your actual row level, like programmatic inputs. So I mentioned that we have, 5 different programs. I have rows that represent measures that were installed across each of those programs. And we're collecting information around things like, categorical information. So what was my measure ID or my measure name? We have the avoided cost subset. What year was something installed? Some typical parameters like my effective useful life. And then you get into what was my admin cost? What was my measure cost? The typical stuff that goes into benefit cost analysis, as well as savings and load shape data. So we also collect those load shapes here, and all of that is configured for every time you want to run a set of OpenBCA calculations. Okay, one last thing before I get to a live demo, and that is to just say, or actually, I'll kick us off here with the live demo. When you open up the OpenBCA, you will see a side panel that has additional resources. One of those resources is a link directly to the National Standard Practice Manual. Another is a link to the actual open source GitHub repository. So for those of you so inclined, you can look at every line of code. You can use this repo, under the licensing agreement, and you can go to the OpenBCA website. And this OpenBCA website, here is where you find all of the information that you would need to get started. So we have the user guide can be downloaded here. We also have a number of video tutorials. So we've recorded tutorials on the use of the input templates, how to actually just get started. Where do I go to download this stuff? How do I open it on my machine? We also have a step-by-step guide on the user interface. We have an FAQ question. We have technical assistance, and here's how you can file an issue. If you use the OpenBCA and you run into a bug, after all, it is software and it's new, you may run into a bug. You can file through the OpenBCA at naseo.org uh, email address. You can just let us know. And you also have a section on IT review and requirements. So if you want to adopt the OpenBCA in your utility or in your jurisdiction, and you want to facilitate IT review, we have a document that has detailed information that will help get your IT team started, as well as just additional general information and system requirements to run the OpenBCA. So if I click on just the OpenBCA logo, it will take me to where I can actually download the OpenBCA. So I'm in currently the most recent version is 1.0.1. And here I just, depending on whether I have a Mac or a Windows machine, I download the version of the executable. I can download the input templates. They've been pre-populated with working data. So it will hopefully help get you started. You can modify that or just delete everything and start from scratch to get going. So here's the entire package. You can download it onto your machine. Now, I've already done that and I've launched the OpenBCA. So here we are, and I already have a set of input templates populated, which are the ones I was just showing you. So right off the bat, you'll see two pages. The first page is called Upload Data and Run the Model. And the first thing I do is just browse files, and I have a folder here which has populated those two input templates. So I'll go ahead and open those. And then you see this red button says upload selected files. I'll just click that. And I'll go ahead and click this button, which says validate the input files. And this will run a series of data checks to make sure that you've entered data where it's required and to make sure that data that needs to sort of talk to one another across the configuration file and the program file do talk to one another. We can map things like load shapes to savings data, things like this. So if any if any of these checks fails, it will also give you a message that will point you in the right direction for where you should focus your QA. Now, I will be very curious if people use this and you pass all of the input validations, but the model itself still fails. I would just request if that happens to you, I'd be curious to know where that is. File an issue through the IT process that I just mentioned, or the technical assistance process that I just mentioned, because we can always add validations. Once that's complete, now I've got a series of green checks, then I can just go ahead and run the OpenBCA. So now all of the matrix multiplication, all of the calculation of benefits across all of my value streams, cost across all of my cost components is being done. And I'm now ready. I got some balloons and I can go to insights and analysis. So this is the most fun part of the entire process here because I get to see the results of my OpenBCA in an interactive fashion. So right off the bat, I get a series of filters that will allow me to drill down into my portfolio of DERs. Right now, the results are just for all five of those programs. So if I look at my list of programs, they're the very ones that I had on the slide a few minutes ago. So I'm looking at the combined impact across my entire energy system plus host customers across each of these five programs that span, 4 or 5 different kinds of DERs. And I've got it all in one place, and I can just get some key metrics. So, these numbers, of course, are all fake. These will just depend on your jurisdiction. But I have a set of total benefits and total costs that lead to net benefits and a JST ratio of 1.13. So I know, hey, my portfolio appears to have a cost-effective set of results here, and I can then look at how are these benefits and costs actually accruing? So I have electric system impacts, I have non-system, I have natural gas tax incentives, I have some delivered fuels, and then I have my cost components, administration and measure costs. And on balance, I have net benefits. And I can also go deeper and I can even look at, instead of these higher level categories, I can get into the specific value streams that are part of this portfolio. So things like capacity and my energy generation and my natural gas O&M and ancillary services and my host customer impacts and it goes on. In addition to that, I may be interested in looking at program level results or measure level results, however I've chosen to configure that input template, whatever a row may represent. It might represent a measure, a program, a portfolio itself, a project that has multiple measures and so forth. In this case, I've kind of gone through and I've done a measure level set of inputs across these different programs. And I can see in the scatter plot how each program is given a different symbol. So my Cool Home Comfort program is shown in blue circles. My Sun Charge program, which is my battery retrofit program, is shown with the stars. And I can scroll down further and I can get temporal impacts of my portfolio of DERs. So I can see, for instance, how my electric impacts are accruing by hour of day and what my actual load impacts were. So the load impacts are shown in red across an average day of the year, and my dollar benefits that are coming from those load impacts are shown in the blue bars. And then I can get a breakout of all of my value streams. If I want even a temporal breakdown of specific value streams, I can get that too. So, for instance, if I want to know how energy generation is accruing versus, say, distribution capacity, I can plot those. They show up as independent traces, and I can see exactly how they're adding to this total set of benefits shown by the blue bars. Maybe I'm not interested in an hourly view. Maybe I'm interested in a monthly view. I can then just in a click of a button, I can toggle and I can get to a monthly view. For those of you who say, I like that figure, I really want to download that figure. I want to make it part of a presentation. I can just click on a button here. I can save this figure, just save image. And you can port this right into whatever application you would like. In addition, in each of these sections, you'll see a display toggle. So a lot of folks like to make their own figures, like to have their own sets of analyses. I can just click on tables. And if I click on tables, now I have tabular information that I can download directly as a CSV file. And I can port it into whatever application I want to make my own figures or do further analysis on these things. So all of that's available to you. Now, for those of you who, and I think this is where this gets really powerful, want to drill down and say, okay, that's great that all my DERs kind of did this holistically, but I kind of want to know like what programs are working, what programs are not working. Or just want to be able to look at one program independently. Let's have a look right off the bat at this Cool Home Comfort program. And maybe within the Cool Home Comfort program, I have two main measure types. I have an air conditioning efficiency and I have a load shifting program that uses smart thermostats. Maybe right now, let's just take a look at this air conditioning efficiency program. I can see that this program, despite my entire portfolio having positive net benefits, this program has negative net benefits and a JST ratio under 1. Well, based on those numbers, maybe I need to optimize this program, or maybe I need to figure out, should this program continue? Well, I can scroll down here and I can see, well, look, a number of these projects actually have positive JST ratios. A number of them don't. Is there a way to differentiate between these projects? Well, I can then toggle over to avoided cost subset and I can see, hey, these projects that occurred in South Junction where I have high capacity constraints, those projects are cost effective. Whereas all of the projects that occurred in regions where I don't have those capacity constraints are not. So I have just within a couple clicks of a button, I have a way to say, okay, what's working and what's not working in this program. If I want to focus this program in this region of my energy system, then I should expect, hey, actually, there is a path to make this program cost effective and optimize these results for the entire rate base. Let's take a look at one more quick example, and then I think we'll pause for any questions that folks may have. Let's just take a look at this Sun Charge program. So this is this battery storage retrofit program. And here I can see I have and I'll just go down to this section here. Let's take a look at how this program derives dollar benefits from the energy impacts. So this is a program that is modeling customers that get a behind the meter battery storage system when they already had a previous solar PV system. And I can see, okay, now that I have a battery, I'm charging that battery in the middle of the day. So that's effectively like negative savings, right? Because that's energy that now has to come from that it's basically I'm not feeding back into the grid. I'm now charging a battery. So it's like negative energy savings. But then I'm discharging that battery during these evening hours. And I can see, oh, wow, look at that. I have significantly higher benefits than the negative benefits that it was costing to charge the battery. And I can even say, okay, I want to look at a very specific peak period. So my peak period in my jurisdiction might be the summertime. So maybe June, July, August, and September. And my peak hours might be, say, um, 16, which I think is 4 to 5 p.m., 17, 18, 19, and so forth. And now I can see, hey, I've got my peak period specifically isolated in the months where I have these peak capacity constraints. And now my value streams are all reflecting just results from that peak period. So obviously with the modern energy system, we have many more areas throughout the country that are suffering from constraints during a specific peak period or electric price spikes during a specific peak period. I can isolate that peak period, get the data from how every single one of my programs is operating specific to that peak period, and I can use that data and understand how my portfolio is performing. So if I toggle back just one more time up here, and I want to look, let's just say I have a small business program as well, and that program also saves natural gas, then I can also, or actually, this program doesn't save natural gas. I'm sorry. Let's go back to my heat pump program. And this program does save natural gas. It's an electrification program, which is why everything looks kind of flipped upside down here because I'm adding electric load, but I'm saving natural gas. I can now look at my natural gas benefits and I can toggle through, GHGs, fuel supply and O&M, whatever my set of natural gas value streams was. So the very last thing I'll say, there's some more information here that you can configure. I didn't even have time to go over it today, but there's a summary results table down here, which gives you all of your value streams, all of your impact categories, all of your cost categories. It's just a comprehensive set of results for every single row that you entered in that program input file. I can just download this directly, take it into whatever pivotable Excel format that I would like or that I need to make regulatory reports to my commission or whatever it is. So everything's here, all the raw data. And with that, I think I'll stop. And I don't know if there are any questions
Thank
in the
you.
chat, but happy to pass the
Yeah.
baton back. Yeah.
Yeah, Adam, there's a few here, and we've answered quite a few of them, but there are some that I think would be one came from Becca saying this is a cool tool. Is there a way for the output to show a variety of BCA tests? Could you look at results of a TRC versus a utility cost test for the same program in an output?
Yeah, good question. So there's not a way to do that like side by side in the UI right now. But what you absolutely can do is configure two sets of input files and just upload the next set and run it. And so, you mentioned like TRC versus UCT. So if I come back here to my configuration file, right here under common data, um, we have a cost treatment set of inputs, and this cost treatment set of inputs allows you to toggle between using only utility system impacts, which is akin to the program administrator cost test, or to use utility system impacts and non-utility system impacts, including host customer benefits, which is more emblematic of a traditional resource cost framework. So if you want to just configure those types of tests, then the cost treatment will, for example, under the program administrator or the utility system framework, it will count the incentives paid by the utility as a cost, whereas that specific component is a transfer payment under the TRC framework or the USI only framework. So that's how you would do that kind of thing. You can toggle between different test types. And then when it comes to things like I want to configure more of a societal related test, that just boils down to which specific value streams you include. So you can include the societal value streams, you can change your discount rate, all of that kind of stuff. So I would just configure that here and then run multiple sets of OpenBCA calculations depending on the specific configuration that you want to look at. So if you have a primary and a secondary test, you do it twice.
And something I want to add here
Great.
is, Adam, if you just scroll over to the configuration data tab,
Yep.
you can enter all of your data here and just use the yes, no toggles on include and test to switch between different tests. So you can keep all of your data there if you say you don't want to, you want to do a sensitivity analysis of not including energy generation in your cost effectiveness test. All you need to do is switch that to no. You can still have all of your inputs populated, but the tool will not take it in as a value stream. So that's another way that you could run multiple cost effectiveness tests using the same set of files.
Great point. And where that will really come into play are things like host customer. So if you don't want to include host customer impacts because you're wanting only the utility perspective on the test, then you just toggle all of these to no, but you can keep all the relevant data in there. And so they're available to you just with a click of a button.
Okay, there's a good question here asking if any outputs, if there are any outputs for non-monetary impacts, such as kilowatt hours, kilowatts, MMBTUs.
Yes. So all of those outputs are so if I just come back here, just as an example, I'll show you a few ways to access those kinds of outputs. So these red dots are all energy outputs, whereas the blue bars are specific to the dollar benefits. So I can toggle over to tables, for example, here, and I can get the dollar benefits straight out. I'm sorry, I can get the savings and the dollar benefits tied to those savings. I can just download them, and I can do that for any set of filters, right? So every time I select filters up here, what this table will reflect are the results that are specific to what I've filtered down to. The table that I mentioned previously, this comprehensive table, also has energy impacts. So here's, for example, electric life cycle savings that are, tied to each of the rows of my input file. And then lastly, for folks who can get at the outputs of a database, the actual under the hood output of the OpenBCA is a .db file, like a database file. And so you can port that into a SQL engine and you can query all of the outputs. So for readers that, or for more technical folks, I would reference you to the README in the repo itself, which will tell you the structure of all of those output tables.
Okay, we have 2 minutes left. I just want to let folks know if your question is not answered here, there are some great questions that we can actually answer and put directly in an FAQ sheet that you can find on the project website. So if you don't hear your answer today, there's one quick question from Marty Hyman. Does the OpenBCA check for symmetry across benefits and costs?
No, it does not. And it's something that we could do potentially as a version 2 of this system. Right now, it's really up to you. And the reason we do not do a specific symmetry check is we don't want to, every time we thought about putting guardrails in place, it led to exceptions where somebody might, for a legitimate reason, want to configure a set of calculations in one way. Maybe it's even just to test the impact that a value stream would have, but they're limited because there's a symmetry enforcement in place. So we've ultimately decided against that. So it is up to you, the user, to ensure symmetry between your costs and benefits. I would definitely reference you to the user manual or the user guide and the NSPM itself for best practices on how to configure your JST.
Okay, we are at the top of the hour. We are going to share one last slide and a reminder that we will be posting the whole deck on the NASEO's NESP page. As far as questions, there's another question that came in about what's the future support for this work? Do we have, will we be inviting intake and comments on the tool? There is a place, there is a contact information here on this last slide, openbca@naseo.org. But if you also go directly into the GitHub, into the tool itself, there is a place, and the user guide indicates where you can make recommendations or bug fixes. Under the issues tab, you can enter what issues you might be encountering, We welcome suggestions for a version 2, and I'm already seeing some in the Q&A box of things that we might consider. But again, we want to thank everyone for being here today. We invite you to ask more questions and to join the office hours. I think there is office hours being held this Thursday. And we look forward to providing technical support to interested states, working with LBNL to help state agencies get started on use of the OpenBCA. So with that, thank you.